Okay, in the last video we solved systems of equations and we solved them by graphing. This time around we're going to solve systems of equations again, but using a second method. Okay, so this time we're going to solve by substitution. And in order to do that, in order to substitute, you have to be able to substitute things that are equal. Otherwise you can't do that. So in my first set of equations, the blue equations, I have one equation that says y equals 2x minus 2, and the other one says y equals 1/2 x plus 1. Because y is equal to 2x minus 2 in this first equation, I can take what y is equal to and replace that y with 2x minus 2. What that does is it gives me one equation, and that one equation only has one variable. I can't solve an equation if it has two different variables in it. So if I can make an equation with one variable, I make my job a whole lot easier. Plus, it is the only way to really solve systems of equations if we're not going to graph. Got to get it down to one equation with one variable. So now what I'm going to do is start to get the x's together on the same side of the equation. You can't solve for x when it's in two different places. So I'm going to subtract 1/2 x from both sides of the equation. 2 minus 1/2 is 1/2, but I like to write that as an improper fraction. So I'm going to write it as 3/2 x. I still have minus 2 on that left side and only a 1 left on the right side. Now to start to get x alone, I have to undo the operations that are happening. I'm going to add 2 to both sides, giving me 3. And the next thing that I do, x is being multiplied by 3/2. So to divide 3/2 by 3/2, we learned back in 5th or 6th grade that you can't really divide fractions. You have to change that to multiplication and flip the second fraction around. So now, hopefully you can see that even though my next step is to divide by 3/2, I really want to multiply by 2/3. So what I need to do is multiply both sides by 2/3. Whatever I do to the left, I have to do to the right. So the nice thing about this, these 2's are going to reduce to 1's. These 3's are going to reduce to 1's, and I'm left with 1x. Over here, my 3's reduce to 1, and 1 times 2 leaves me with 2. So x is 2. All right, I'm half done. Yeah, I know. You probably are thinking, all of that work. You got to find the y value that goes with it. Finding the y value is a whole lot easier. Actually, I should say finding the second value is a whole lot easier. Sometimes you'll find the x value or the y value first in our other methods. So the next thing I need to do then is take what my x value is and again substitute. You're going to substitute twice in this process. You can pick either of the original equations that you want and replace the x with a 2 because now you know that x is equal to 2. So I'm going to take the first one. Y equals 2x. Well, we know that x is a 2. So 2 times 2 minus 2. 2 times 2 is 4. 4 minus 2 is 2. So now we have the point 2, 2. You might remember that from the graphing video. I don't know if you noticed in your notes, I used the same exact equations, but this time I solved using a different method rather than graphing. Okay, I might need some of this space. We'll see. I'll leave it there for now, but if I need the space over here to solve this second system, then I might have to erase some things. So again, just like the last one, we're going to substitute. And we're going to substitute 1/3 x plus 2 into the second equation. Okay, so the next thing I want to do is get my x's together. You'll notice it's kind of a similar process as the last problem, only we're dealing with different numbers here. So we've got 2 1/3, And thinking ahead to later on in the problem, I think I want something different than 2 1/3. I'm going to change that to 7/3. 7/3 is the same thing as 2 1/3. If you need me to go over with you how that is, ask me after the video and I can help you figure that part out. Okay, now I need to get the x alone, and I'm adding 2, so I want to subtract 2. And that's -7. Now I have a similar situation to what I had a little bit ago in the other problem. Here I've got this 7/3 right here I need to get rid of. Just like over here I had a 3/2. I ended up multiplying it by what's known as its reciprocal. I don't really want to use the blue, but it's a bigger dot, so I like the bigger dots for multiplication. So if I multiply 7/3 by 3/7, which basically is the same as dividing by 7/3, some good things are going to happen here. Even though fractions you don't like, some things with fractions turn out pretty nice. So now that I multiply by its reciprocal, the 3's reduced to 1's, the 7's reduced to 1's, and I'm left with just x. Over here, some other nice stuff is going to happen. These 7's reduced to 1's, which is a -1 times 3 is all that I have left. So let me make this one a little bit bigger. -1 times 3 is -3. So in this system, x has to be a -3. But our answer is only half done. We've only found the x value. You can take that x and plug it into any equation that you want to. I know that many of my students do not love fractions like I do, so I'm going to not use this first equation because of that fraction, although you could. I'm going to use the second equation. Y equals -2x. Well, we know the x is -3 now, so I'm going to change that x to a -3 instead of a variable. And then I have a -5 at the end. And I'm going to do this math to help me find out y. -2 times -3 is a 6. 6 minus 5 is a 1. So the solution to this is -3, 1, which, if you noticed, these were the same equations that we graphed when we solved by graphing. And we also got -3, 1 as our solution when we did that. Okay, so solving equations by substitution. Solving systems of equations by substitution.